Not there.
Alrighty. 29-4 day 1 notes. The only difference from this section and the section we just got done doing is this is in 2 fractions and we've just graphed single fractions. Have we learned this year how to take 2 fractions and combine it into 1? Yes, we've subtracted fractions, just like if I had a fifth minus 2/7. We've done that before. We get a common denominator. Here's what I don't want you to do. It is legal. You can do it. It's more work. Don't do this. Some of you see this, and on your quiz like this, here's what you did. You said, oh, those don't match, so I'm going to multiply by this one, and I'm going to multiply by that one. Let's not do that. That's more work, which means more likely to make a mistake. Let's instead factor anything that's factorable, which in this case is only the second fraction. There's a GCF of x. Go ahead, factor out that greatest common factor of x. This is all today, no calculator. Tomorrow, no calculator. Now you can see the denominators are kind of similar. This first one needs to get multiplied by x so that it has a common denominator. What do I do once they have a common denominator? I keep the denominator the same, right? I do whatever it says on the top. So in this case, it says subtraction, and I keep the denominator. So here is my function. We all know that this is the exact same as this. We've graphed these before. We're not great at it yet. We have not graphed something that looks like that. So that's why we changed it. Okay. Does the top factor?
No.
Do the top and bottom have any common factors? So what does that mean in my graph? There's going to be no holes. Write down no holes so I know that you checked it. No common factors cross out, which means this graph is going to have no holes. Who can tell me something about any vertical asymptotes? Jillian?
There's 2 of them.
Yes, what are they?
0 and positive 2.
X equals 0, x equals 2. I look at my denominator. X can't be 0 because of that guy. X can't be 2 because of that factor. I'm going to plot things as I go. If you want to plot it all at the end, that's fine. So if you're doing it with me, let's plot a vertical line at x equals 0. The vertical line at x equals 2. How many pieces will this graph have? 3. The outer 2 will be sort of curves. The outer 2 will look something like this. The intersection, or the middle section, is going to look maybe like one of those pieces. We'll figure that out together. Horizontal asymptotes. I would look here. I wouldn't look at the original. What's the degree of the numerator? 1. What would be the degree of the denominator? 2. Even though you don't see an x squared, we see an x times an x, which would be x squared. So maybe look back at your paper from the last set of notes. The denominator's degree is larger. Why? What would be my asymptote?
0.
Yes. Y equals 0. Let's plot. Y 0.
So like last time's notes, I have that we had one outer graph and then like it looked like an X cube.
Okay. Yeah.
One in the middle.
Right.
Why didn't we not have one on the outer side? Did I just do it wrong?
Every graph should have, like, it would have had 3 parts.
I'm not gonna lie, we probably just stopped.
Remind me at the end and I'll come look at it specifically.
Okay, thank you.
Are there any questions on vertical or horizontal asymptotes for this question? Am I allowed to have points on a vertical asymptote? No. Am I allowed to have points on horizontal asymptotes? Yes. It just means it's approaching that number. So it's approaching 0. If it touches it and gets close to it, that's okay. Okay, I'm going to erase this. Next thing, oopsies. Next thing we're doing is x and y intercepts. X intercept. You remember how to do that. You set y equal to 0. If you're thinking that looks complicated, let me give you a hint. If I make this a fraction, its denominator is 1. 1 times anything is itself. Cross multiply this way. 0 times anything is 0, which is essentially always just the same as setting the top equal to 0. Questions on the x-intercept. Let's plot it. 3/2 is 1.5. Okay, find your y-intercept. Well, that's kind of odd. You can't divide by 0, so this means there is none. I would write none. So your graph will not touch the y-axis, which makes sense because that's your vertical asymptote. Shouldn't. Okay. Do we have questions there? Now comes probably the harder part, kind of the newer part. How in the world do I make a graph out of just that? Well, we know we're going to have 3 pieces. Let's do the outer piece first. So let's plug in a -10. Go ahead. Plug in -10 for x. We'll see what the height ends up being. Probably the largest number you'll ever have to plug in without a calculator, 10 and -10. I get -23/120. So way out here at -10, I know I'm negative just a little bit. Okay, I want you to try on your own. Try to make the graph of this section here. What do you think this piece is going to look like? Keegan, what you missed was I just plugged in -10 because I didn't have any information here. So I just plugged in a number, -10. I found out it was negative, so I know this point. Now they're filling out the rest of this, which I'll walk through with you. We don't have any x-intercepts. So my graph isn't going to do this because there's no x-intercept. So the only choice for my graph is this. Hopefully that's what you guys have for that section. That's all the more detail you have to be. It can't go up, because then it would cross the x-axis, and we have found out that there are no other x-intercepts except for the one plotted. Let's do this section over here. There's no information, so let's plug in 10 and at least get 1 point.
Yeah.
Yeah.
Alright. I got a positive value, so I know I'm gonna have this point here. Have you guys finished this graph on this side? There is no x-intercept, so it's not gonna be one of those kind of curves. It's gonna have to kind of be bounded up this way. Alrighty, the middle part, which is the trickiest. Here's one thing I mentioned in the last lesson. If you look at an asymptote, and on this side of the asymptote, the arrow's going down, what's gonna happen right on the other side of the asymptote? It's gonna do the opposite. So this guy is going up.
With that,
It's okay, just wait. Every vertical asymptote will have an up arrow and a down arrow. So because there's a down arrow here, on this side, there's an up arrow. So if you look at this asymptote, this one has an up arrow, so that must mean there's a down arrow on that side. Kind of like train tracks. They've got trains going both directions on each side of each vertical asymptote.
I might be jumping the gun here. How do you know if it's for?
No, Jillian, well,
I might be jumping, but how?
So we have to now connect this arrow, and this dot.
Wait, can you just?
How is that about
Having down would make it.
The middle section will always look like this, or flipped, or like this. The middle section, if there are three, will look like an x squared graph, or it could look like an x cubed graph. This one, because I have to connect these three parts, the only way to connect an up arrow, a down arrow, and this point is to do that.
I don't understand why it is the way it is. So like, why is that? Why is the one arrow on this side and then this
Because-
instead of like that?
On this vertical asymptote, every vertical asymptote, on one side, there'll be a train going up, and the other side, there'll be a train going down. So here, there's a train going south. So on this side of the asymptote, there's got to be a train going up, like right by that line.
Oh,
And so with this asymptote, there was one already going up. So right on the other side, there's got to be a train going down.
oh, that makes sense. Okay.
So then I had to connect just whatever was left in the middle, I had to connect all those pieces left.
What variation of outside graphs would get you a parabola? Because if it's like
The-
diagonal.
The outside graphs,
Oh, if it was like two to four.
we'll do one.
Okay.
You will get to
If
one.
I had like an example of equation, that would like.
Yes.
What about like 1 over x squared? That's not following the both different rules because they'd be like that.
1 over x squared is our parent function. This goes down.
1 over x squared. Graph 1 over x
Oh,
squared.
I don't have time to do that now, but I will do it when I'm done.
Because it's like this.
I'll do it when I'm done. And this question may answer that for you.
Okay.
It will, actually. Number 2. Notice it's already factored for you. Let's start with holes. Are there any common factors in the top and bottom? So what is the hole going to be?
0.
No, ooh, don't say
None,
0.
none.
No holes. Vertical asymptotes. Look at your denominator. What do we think?
Oh, God. Can I cross out?
3,
Can I cross out squared?
I was joking.
Oh, okay.
3, negative 4,
But not 3, but
x equals
x equals 3 and
x equals negative 4.
good. Now, this is important here. That's the same as writing x plus 4, x plus 4. When that happens, when you have a repeated factor or a repeated vertical asymptote, I need you to put a star there. And I will tell you how that affects your graph. Please plot vertical asymptote of 3. Vertical asymptote negative 4. And put a star at that vertical asymptote that was repeated.
You remember the repeated root thing? Right? Didn't it like bounce?
Yeah.
It's gonna be, yep. You'll see.
What about
Horizontal asymptotes. What do we look at for horizontal asymptotes?
the lead degree / coefficient?
The degree first. So the degree of the numerator. That's not possible. The degree of the numerator is
3.
degree. What will be, if I put this in standard form, the highest power is going to be x to the second.
Yes, you're so smart.
But like x times x is the x squared and then times x again, right?
It will be 2x
Oh,
times x.
the numerator.
Yeah.
Your denominator, we're not looking at coefficients or anything. We're only looking at degree. If I were to put this in standard form, which please do not do, what would be the highest power on x?
Cubed.
Cubed, because this is going to be x squared. Another x is x cubed. We only need the coefficients if they're the same degree, and they're not. So if the denominator is larger, it is y equals 0. How many pieces will this graph have? 3. We'll do the outer pieces first. We'll do the inner piece next. What else do we have to find? Intercepts. X-intercept means y equals 0. Did you remember it only has to be the top? If you forgot, okay, we'll do all of it. Here's y. It only has to be the top. If I were to multiply across, this would be 1 times 0. Do I want you to distribute that out and put it in standard form? No. You guys have done this before. This is like zero product property. If these are being multiplied, my answer is 0, set each factor equal to 0. Very quick, actually. Plot those x-intercepts, -1.5, -5.
Wait, I thought there wasn't supposed to be.
You can have points on horizontal, no points on vertical. Next is y-intercept, set every x as 0. Bless you. So there's a little math you'd have to do in your head. I wasn't sure what 3 times 4 times 4 was, so I did 4 squared, which is 16, times 3, I got -48. So my y-intercept is negative just a little bit. Alrighty. Let's do the outside pieces. Let's start with this section over here. I don't know if the graph is going to do this or if the graph is going to do this. I don't know. So if I had a point out here, that would be helpful. If the point is here, go up, because a graph will never do this. Have we ever graphed anything that looks like this? No. Don't try to go up and then straight back down. So we need to plug in -10 and see where our graph is before we do that. Could we plug in -10 here? Yes, we could plug that in for x's. Let's think about this. If this is 0, do I really care the number? Don't I just want to know if it's positive or negative? Don't really need the number, I just need to know if it's positive or negative. So if I were to plug in a large negative to this parentheses, what would I get? 2 times a large negative plus 3. Would it be positive or negative? Negative. If I were to plug in a large negative, what would this parentheses be? Negative. If I were to plug a large negative in for x here and subtract 3, I would get a negative. Put in a large negative here, add 4, I would get a negative, but then I'd have to square it, right?
Yeah.
What's a negative times a negative? What's a negative times a negative times another negative?
Negative.
3 negatives would be negative. So when I plug in a negative 10 or a negative large number, a positive over a negative is going to give me a negative. So plug in a negative point at 10. It's okay if you didn't fully follow that. We'll practice it more tomorrow. You can plug in 10 if that's helpful, but we didn't have to for this one. Now, everybody please try to make your graph just this piece. I have to connect the 2 dots. Again, we can't go, we've never had a graph that curves like that. So that must mean they don't connect like that. That must mean this just keeps going up. Questions? Do we need more time? Okay, please do the outside sections first. So let's look at this section. There is no information. Let's plug in 10, or do I have to be specific at 10, or could I just figure out if it's positive or negative?
Positive.
Yeah, I'm at 0, so let's imagine plugging in a large positive, like 10. If I plug in 10 here, I get a positive. Plug in 10 here, that's going to be another positive. Plug in positive 10, be positive. Saves me from calculating an actual number. So the numerator is going to be a positive times a positive, which is positive. Denominator is going to be a positive times a positive times a positive, which is positive. So at 10, I'll have a positive value, an above 0 value. All right, make that outside piece.
No.
Can my graph
Can make it.
do this?
Yeah.
It's allowed to touch the horizontal asymptote, but wouldn't that be an x-intercept? Do I have an x-intercept there?
No.
I have found all my x-intercepts already. They've all been plotted, so no more will I be allowed to touch the x-axis. So the graph's going to have to do this.
Exactly.
All right, let's talk about the train tracks again. Here's what I meant by the train tracks. If this is my asymptote, one train will be going north and the other train will be going south. So over here at this train track, this guy's going north, so this guy's got to go south. Here's where the star comes in. See this star here? That's special. That came from a repeated asymptote. In that case, trains are going the same way. If there's a star, a repeated asymptote, your trains are both going to go the same way instead of opposites. That answers your question from before. So this train is going up. It's got to go the same way. So I need you to connect all of the pieces that are in the middle chunk. Your middle chunk will always look like an x cubed graph, or the reflection of, or an x squared graph, or the reflection of. That.
Okay, this one's better.
Good.
It makes more sense. I feel like it was too small.
So if there is a star,
Mhm.
you would normally make it a parabola, you make it that and there's a star.
The star doesn't make the parabola. The star makes the trains go the same way. This one's going north, this one's
Just
going
on
north.
that one.
If there wasn't a star, it would have been a problem.
It would have been a north and a south, and yes, Lydia, did you hear that?
Yes.
If it wasn't a star, yep, we would have had to go this way, and it would have been a parabola. Good.
I'm
right.
going to redraw that graph.
There are only 2 questions for tonight's homework. I do want you to switch a number that got mixed up on tomorrow's. So look at tonight's homework. You're only doing question 1 and 2, but please flip to number 3 for tomorrow's. You have to change something. Number 3 and 4 will be tomorrow's homework. Please change the second fraction. Yours probably says x squared plus 8x plus 1. Please change it to x squared plus 8x plus 15. Alrighty. Hopefully we're feeling better about this stuff. Again, tomorrow's nothing new. We're just going to practice 2 more and do 2 more for homework.